Okay, so as you can see, I've done out all the work already. So the reason for that is because the sound went on my previous one, which is not ideal. So this is 11.4. This is y equals mx plus c. Okay, so we'll start off with, if normally what we were given was an equation like this, 3x plus 2y plus 4 equals to 0. Yep, easy enough. Now, I want you now to put y first. So we want y's on one side and everything else on the other side. Hence that y equals mx plus c. It's not 2y, it's y. So we get y equals minus 3 over 2x minus 4 over 2. So what comes right before the x when this is y is the slope, minus 3 over 2. Just like this one, y equals 3x plus 2, slope is 3. Now, Harry's going to ask, what is this number 2 here for? And this minus 4 over 2, which is minus 2. That is actually the y-intercept. Okay? Which brings us to here. Oh, yeah, they both fit in nicely there. So, I'm looking here. That's this line. The 2 is the y-intercept. This is the y. This is the x. That intercepts the y there. Now, how do I do this? I could find this point easy enough, but I want to just do it doing slope of a hill, how far it goes up to how far it goes across. So it's rise over run. This is 3, which is the same as 3 over 1, which means it goes up 3, 1, 2, 3, and goes across 1. That's our next point. Join the 2 points, we've got an infinite line. Just like this pink one here. That represents this line. Minus 2 is where it intercepts the y-axis. And then it's minus 3 over 2. So the rise is minus 3. 1, 2, 3. And it goes across 2. 1, 2. Dotted. And there's a line drawn. Okay? And that's all you do. These are examples of all parallel lines to it. Only difference is the y-intercept. So if I was going, we've got any parallel line I could do for this one, let's say this one here, would be 3x plus 5, 3x plus 10, 3x minus 4, 3x minus 768. Okay, and there's an example of one. Okay, for this line. If I was told find the parallel line to this, 3x plus y, we need to get y, and then just come up with any. To get a perpendicular to that lovely line in the circle there, all we do is, well, we know the slope is minus 3 over 1. Minus 3 is the same as minus 3 over 1. Then we go perpendicular slope 1 over 3. Y equals mx, 1 over 3x. Add in any number. It can be any number in the world. So plus 6. Now, this one is saying line L, line K, are they perpendicular? We need to get this in terms of y. So bring over the minus 3y becomes plus 3y. We can make it 3y equals 2x plus 6. Divide across by the 3. Tip both. And we get 2 over 3. M is 2 over 3. We do the exact same on this side. And we get m equals minus 3 over 2. Multiply them together. Minus 1. Bob's your uncle. We're laughing. Now, this side. Whenever it crosses a y-axis, the x value is 0. So if they say, here's the equation of a line, find the x value. You put in 0 for x. 3 by 0 is 0, plus 4, that's 4. Our point is 0, 4. Just like here, if I just sub it in, 3 by 0, plus 4y, bring over the minus 5, 5. That's 5 over 4, 0, 5 over 4. Done. Easy enough. Nothing too groundbreakingly hard there. Now, question 16 is here. They give you this point. You got 2 ways in which to do it. They just tell you this is 3, but we know it's 0, 3. This is 2, 7. We can find out the slope by that. Or we could go, well, how far across does it go? From 0 to 2, that's 2. How far does it go up? 3 to 7, that's 4. 4, rise over run, 4 over 2, that's 2. 2 ways to do it. Your Homework! Monday, question 1 to 9, and Tuesday, 10 to 17.